Hello, we got ourselves a new project. I'm working on a crankshaft for a 200 TDI motor. It's going to be built into this Land Rover that currently has a 2.5 liter petrol engine. Here's the new one. It needed new bearings, as you can see. The old ones, the piston bearings or the piston rod bearings, and there's the crankshaft bearings. So that wasn't all too good, and then I also decided to fix up the leak of the rear oil seal. Now this flange, if you will, was 99.5 millimeters and had a terrible groove in it, a wear groove. And I tried to find a speedy sleeve, but they're made for a 100 millimeter shaft, so they're too loose on this. And then the next step back is 95, I think. So I don't want to turn it down too far for the next speedy sleeve in line, because then these threaded holes might be in jeopardy. So I need to make a collar out of stainless steel that will fit over there tight, snug fit. So I've taken this, I've bought this stainless steel tubing, 3 or 4 stainless tubing, and I try to turn off a piece, and as I expected, it loses its shape. So I want it to be perfectly round to turn everything within the spec to fit the crankshaft. So what I've done now is I've turned a wooden hardwood core that I will put inside before I put it into these, well, I call it a claw. Translated from Dutch, it would be a claw. Don't know what it would be in English, but anyway, put this inside the tube and then put it into the claw so it will keep a shape. So this shape is now exactly the inner shape of this tube, and then we'll start turning it into size on the inside, put it on the crankshaft, and then see what the outside looks like and whether it will still fit a normal size oil seal. I got a new one already, so we'll see how that comes out, and otherwise I might have to turn it down just a little bit more. So turning it down in the lathe works very well actually. It's very well balanced, so it's no problem in spinning it at a high rev. I've made this little bush. You see how tight it fits? The air keeps it in. There you go. To keep it in the centers. So you could make a pump almost like that. Anyway, so that's it for now. So here it is, tapping it in. It has a pretty nice fit, and I've used this bolt, this M10 bolt, and on the other side in the head I drilled a center hole. So I'm going to leave it in. And I might be using it later after I've cut it off. You see, I've taken about, let's see, I need 20 mils. So this wooden yoke is 70 mils. So if I take 100, I should have enough clearance to make a 20 millimeter speedy sleeve or wear sleeve. let's have a look. As you can see, still there's some little spots that you've missed. There's a weld. If I look at it from the outside, I don't really see it. So let's see if I take just a little bit more off, then we might be around. We're now at 97.45 and we should be aiming for 97. 99.35. So we'll see what happens. So we're at 98.4 now. As you can see, there's not really a trace of a weld anymore. So that's good. You can't hear it when you turn, and you can't hear it anymore either. So 98.4. Let's go to 98.8. And then we're getting close to where we want to be. Let's see what the wall thickness does. So I went from the inside turning one more pass on the outside, and as you can see, it's still very much eccentric. So it seems that hardwood did its job. And we'll do the final pass on when it's installed on the crankshaft itself. Now I got to be absolutely sure that I'm done before I take it out, because I will never get it in the way I've got it now. So but this is probably the last pass. So as you might be able to see, is that on the inside I've turned over there. I've turned just a slight edge, so that will serve as a seeker before so that I can tap it on straight. So the last pass worked out fine. It's really smooth now, and I think I'm ready to take it out. We'll do one more measuring check to see if it's really round. But then again, when I put it on the flange, that will probably shape it. So that's good. So I've cut the ring off. I left some excess to tap on and to hammer on. So that side's going to be slided on. And I've cut it on the wood so I'd have some support, because it's a real pain to get it off. Stainless steel anyway. So okay, I guess we're gonna try it on. Okay, there it is. And we're just ever so carefully tapping it on. Now it doesn't matter if I tap here, because I'm going to have a lot left, and I'm going to remove this bit on the lathe anyway. And I got an edge in here, inside here, so I can tap it snug with that edge. probably put the ear mufflers on. I can hear we're coming home. There you go. Yeah. And we're home. Look at that. That's beautiful. So I want to put this all together in the lathe, and then it's going to be somewhere this size. That's beautiful. And then in the end I'm going to have to polish this so I don't have that screw, that thread effect that will actually pump oil under the seal. However, I've made this with a very, very small pitch, so it won't be much, but I'll just touch it up with a very, very fine sandpaper. All right. So we're making the final pass here. This will be pretty round. All right. Put some oil on there, cool it down a little bit. So we made the final pass, smoothed off the edges so we can get the O-ring on properly without damaging it. And then we'll probably use some sand and paper to get that screw effect out, although it's very smooth, but we'll do it anyway. And that's it then. Ready for a new oil seal without leaks, I hope. And in case you're wondering whether it's on tight enough, I've really turned this stainless steel down in the lathe and it didn't move an inch, so I guess an oil seal won't move it either. Good to go.